Thank you. Before I start, last time I did a conference talk similar to this in content, and I got some data that was very useful for me. So I'd like to do some exercise for me. See if this works? Yes. Can you put your two hands forward, please, for me? Just your two hands, the right hand and the left hand. Don't worry, I won't ask you to hug your neighbor. Thank you. What I'd like you to do is, on a grade of 0 to 10, I'd like you to grade yourself on your ability with AI and understanding of it. And just be fair, just be honest with it. It's not a test. Just go across the board. This is, similar to roughly last time. So go from 10 to 1 to 3 or 4, and it's kind of a normal distribution around 5, 6. My expectation through this talk is that if you scored really high, it's to give you a different perspective to how to look about AI. And if you scored really low, is to raise that level to give you a little bit of demystifying the domain in itself. So let's start. AI recently has actually been linked to, well, it starts with a human brain. It's not the same that it was about 60 years ago when the terms were actually coined. And the brain is where we actually think, apparently. It's rather complicated. But if you drill in, you see cells. The brain is mostly built up from neurons. And neurons are rather quote-unquote simplistic in its overall behavior. It receives signals from someplace through its dendrites. It does something in its cell and sends a signal further down the road to another one. And that's where the paradigm today about AI says, well, I can do that. I can do that artificially. I can create a model that says I get my omega I, xi weights from previous neurons. My cell is doing something, is aggregating that data to a certain level, and then if it's excited enough, it's going to send it to the next level. Voila, I've created an artificial neuron. How do I go back to artificial intelligence? Well, DNN, I just stack them. I just add a bunch of them, and somehow it should work. And my point is that AI is a little bit more than this. You have really three core dimensions when you think about an AI problem. Data, something to learn from, the goal, what you're trying to achieve, as well as the algorithm that you're going to use to learn from that data to achieve that goal. So let me give you an impression of what is a 0 on each and a 10 on each. So let's start with data. If you score low on data, you just think that data pops up in a cell, let's say in this spreadsheet, and that's it. You don't know where it comes from, you don't know what it stands for. A 10, on the other hand, is imagine that number is actually the number of profile views you have on LinkedIn. So LinkedIn is an application. If you look at the app, at a profile of somebody, and this is my profile, every time somebody looks at a profile of anyone, it should increment that counter +1. How does that happen? Well, it's actually a very, very complicated process, which starts with you need to define what that metric is. And that's not trivial. If you think it is, it isn't. Especially if your company grows, it's very, very hard. There's lots of data governance issues around it. So now you define what you want to metric, what is your data. Then the next step is, well, how do I emit? In the end, it's the app. How do I put the code within the app that's going to emit the +1? How do I do that right? That's also not easy. Then that data gets to your data centers. Once it hits your data centers, you need to have the ability to collect it without loss. Once you collect it without loss, you need to aggregate it across different points. Once you aggregate it across different points, now you have an ability to put it someplace that you can process. And sometimes the data needs to be processed very intensely because the logic is very hard or intensive. And after that, you can publish your data set and you have a source of truth. And this whole thing is kind of a circle because that data set, that source of truth defined by the first definition. And then that pops into your cell. That is super complicated. If you don't believe so, or if you think it's super simple, I'm certainly free to stay after this talk, and I would love to hear your opinion about it. In my experience, it's very hard. So that's data. What about goals? Well, you can express goals in verbal form, It could be to create economic opportunity for every member of the global workforce, which is LinkedIn's vision. You could say that it's to organize the world's information to make it universally accessible and useful. That's Google's mission. A goal could be to empower every person and every organization to achieve more, which is Microsoft's mission. Or it could be to be the Earth's most customer-centric company, which is Amazon's. Those are all goals. They're corporate goals, but they're goals. Or it could be to build great products that John Ivey defined Apple. Or it could be to create delightful experiences, or to increase efficiency and productivity, or to simply say, I want to win the chess game. Those are all goals. And if you stay at that level, that's probably a 0 or a 1, because sometimes it's really hard to actually really formulate a goal. A 10 looks a little bit like this. 10, 1. If you didn't see the difference, 10, 1. Okay, let's go to 10. Actually, it's a little bit more complicated than this, because this, anybody can write. You can write a complex mathematical formula, and that's it. What is actually really hard in formulating the goal is how do you relate that objective function, which is this one, to the goal that you're trying to achieve. That's certainly not trivial. The goal itself is hard to define. And the first thing you can think about from a goal is how you're going to measure whether you're achieving it or not. And those are really long-term metrics. From an AI perspective, long-term metrics don't really work for you, because as you're going to push your system, you want it to learn very quickly. So it needs to have very short metric. So there's a gap between these long-term metrics, the short metrics, to the objective function. And scoring really high on goals is you have an ability to reason all the way through, and you understand what the issues are as you go down step by step or up step by step, because nothing is a perfect relationship. And that's a 10. Okay, let's look at the last one, algorithms. A 0, a score very low in algorithm, for all what you know is it may be an API that you call, and somewhere there's something that says push here for the algorithm, and for intensive sake of purposes, if you do act upon it, a clown would jump out of the box. That's a low score. It's interesting to see what a high score is, really. So I tried to illustrate it within this picture, because it constitutes of two things. The first one is you need to be able to think theoretically about your algorithm. Whatever technique or whatever thing you use, you need to be able to reason around it. Understand what are its assumptions, understand what its shortcuts or whatever it's doing. You need to really feel very good about it and understand it very intensely. But that's not the same thing as implementing it, because in the end, that code needs to work. And theory to reality through code has a lot of shortcuts that you need to think about. For example, DNNs tend to over-parameterize. Well, how do you deal with that? Or if you create the topology of your neural net in the wrong fashion compared to the hardware that you have, it's going to overrun your network I/O. So AI has these three things: data, goals, and algorithms. So if you want to think about a success and a democratized AI, how do you go about it? So from an organization perspective, certainly the first thing you should do is figure out where you sit. Where are your gaps? And this is a little chart, a spider chart. If you're at the middle, you scored very low. If you're on the extreme, on the vertices of every single one dimension, you scored very high. So the company in blue is scored very high in algorithms and very high in data and very low in goals. So then essentially, you don't know what you're really doing, and your AI is iterating in the empty space. The company in red is really good about transcribing these goals. It's really good about implementing and thinking about theoretical in AI, but it doesn't have necessarily the data, or the data is not complete or corrupted. The classical garbage in, garbage out. So what I'm saying here is that you can't ignore one dimension compared to another one. Now, how to think about a successful AI? Well, it all starts with what? What is the first thing that you should think about? I gave you the answer already. So it all starts with formulating the problem. Think about what you're trying to do. I was at a recent discussion with Andrew Ng, and he actually phrased that slightly differently. And what he said is, AI by itself is completely useless. It's exactly the same thing. So you need to formulate that goal. You need to understand what you really want to do. Nobody can do that for you, so there's not really any shortcut. Once you formulate the problem, what is the next step? Can I go directly and implement? Well, no. I need to figure out what is the data that I have. I need to collect that data. What do I mean by this? How can I get better? How can I democratize it? Well, I described to you the whole data pipeline issue. Well, today you can democratize it in a sense that you don't have to implement it yourself. At LinkedIn, we open source Apache Kafka, which was a pub/sub messaging queue. And we also open source our Apache Samza, which is a streamlined processing. You can use that off the shelf. You don't need to build it on your own. If you're using a cloud provider, they also have different tools accessible for you. So that data thing, the pipeline's in the middle. You don't have to think about it. You can democratize it. What about getting data sets? I don't have enough data. Can I reach out and get other data sets? And that is yes and no. Because most likely your problem is rather specific. Now, if it's about pictures and recognizing things in pictures and objects, then yes, you do have a lot of data around that. But that may not be what you're going after, what you're trying to formulate, the problem that you formulated to solve. Labels. Once you have the data, I need to label it. The interesting thing here is that there's lots of tools out there to help you label at scale, like crowdsourcing. The problem is that very often, they're not necessarily that well labeled. And if your data is not necessarily that well labeled, that's that much more that your AI needs to circumvent to get better at it. So it's actually hard. So it's not necessarily distributable. And finally, I would just highlight that the schema of your data is something that's really, really critical. Because if you define it wrongly, you have to do a lot of cleanup to get it back. And you can't necessarily democratize it, because it's actually really hard. Of all the problems that we've done at LinkedIn, that is the one that we constantly have to go back to, because there's a lot of entropy once you define it, because the future is not necessarily the same thing as the past. So on one side, we said formulate the problem, collect the data. So what's the next step? Now you're in business, you can build models. Can you think about democratizing it? Well, here's an example. This is from ML Core. Just copy-paste it from the website. ML Core is an iOS library. And what it basically says is, take a picture. That's my pixel buffer. I give that to a model interface, which will give me back some prediction. And if everything runs correctly, I'll get class labels afterwards. What model? Well, you can download models from either GitHub or Apple or different places. So in that case, you don't have to do anything. If this is answering your criteria about what you're trying to achieve, it seems to work. Right? But if you think further, well, there may be something, a little bit more. There's different things that you can start thinking about. You may have some pictures or some data that's slightly different, but you can still use that model as a base point upon which you can extend. And that's essentially what, let's say, transfer learning is all about. It's almost like the data that you're getting through a model is actually your prior. The data that you have is slightly migrating that prior, that parameter space that's been found through that technique, that model, to something slightly different to where your data is. It could work. So it is democratizable. Or if you don't have a model, you can go back and look at the literature. And for any of you who have built AI systems from literature, you know that that's kind of hard. Because the devil is always in the implementation details. I can describe you a technique, how it works. What are the little shortcuts that made it to converge is actually not that trivial. It's very, very hard. But it gives you a head start, so you can kind of democratize around it. But the decisions from your model, those ones are your own. You can't delegate that to anyone. You can't delegate that responsibility to anyone. You can't necessarily evangelize and democratize around it. What I mean by this, in the example that I have over here, there's multiple ways that you can think about that label. You can pick up from the method, give me the label that has the highest probability, or give me a label that's above a certain threshold. If the threshold is too low, don't give me anything. So what that threshold is super critical for your application of what you're trying to achieve. The consequences from these can be rather drastic to the individual who's using your application. Hence, the decision is really something that you need to think very, very hard about and not necessarily delegate. You can't just ignore it because the consequences from that applications are yours. So to build successful AI, I said there's three things really. Formulate the problem, collect the data that you need for that problem, and then go and build models. So how do you do it at scale? If you have a large organization, how do you actually get better at it? And the only thing that I can think of is what we've started to do at LinkedIn. It's an AI academy. Teach. Go back to first principle. Just teach. There's a lot of individuals that are very interested about it. They may not know. They may score a 0-1 before. Just teach them. Get them with a certain ability. Figure out what are the problems that they can iterate and get them to grow within it. And that's possible. If that other individual is also willing to learn. So I've framed AI in three spaces: goals, data, and algorithms. And I give you a little bit of how to get going. And in the end, teaching is what will get you out of and building up with scale. Thank you.